Okay, so something huge is happening in the world of construction. For the first time in more than 20 years, the absolute bedrock rulebook for concrete in India, IS 456, is getting a complete makeover. We're talking about a massive 400-page draft that's out for review. And trust me, it's proposing some of the biggest changes the industry has ever seen. This is all part of a global shift towards making our infrastructure smarter and way more resilient. You know, we spend our lives in and around these massive concrete structures, but do you ever stop and wonder, what are the actual rules that keep them from falling down? These codes, they're not just guidelines. They are the fundamental science that engineers use to guarantee our safety. And let's be really clear about this. This isn't just a few minor tweaks here and there. Nope. What we're looking at is a total philosophical shift in how we approach concrete design in India. It's basically a complete reboot from the ground up. So the single biggest change is this move away from what you could call a recipe-based code. The old way was all about asking, did you follow the steps in the cookbook? But the new way, it asks a much tougher question. How is this building actually going to perform over its entire lifetime? It's a huge difference. All right, let's dive into the first really big rule change. From now on, at the very beginning of any project, designers are going to have to classify every single structure. And they'll do it by answering one simple but pretty heavy question. What are the consequences if this thing fails? And this is where it gets really interesting. The new code creates 4 official categories. This classification, whether it's a normal local community hall or a special structure like a nuclear power plant, is going to dictate every single design decision from that moment on. But here's the catch, and it's a big one that engineers are already talking about. The definitions are kind of vague. I mean, think about it. Is a huge international airport critical with national impact or just important with regional impact? The answer matters, because one might need incredibly complex and expensive analysis that the other doesn't. This ambiguity could spark some serious arguments right at the start of a project. Now, this whole focus on performance leads us straight to the next huge change. The very definition of what we consider a good design is about to get a whole lot broader. And when you see it laid out like this, the jump in complexity is just, wow. We're literally going from 2 primary concerns, strength and serviceability, to 6. This forces engineers to think about the building not just on day 1, but over its entire life cycle. So these 4 new pillars, they're all about resilience in the long run. It's not enough for a building to just stand up anymore. Now it has to be durable enough for its specific environment. It needs to have backup systems, it has to be repairable if something bad happens, and it's got to be tough enough to handle unexpected events. So you're probably asking, okay, how on earth do you design for all of this year's stuff? Well, the draft introduces a completely new workflow. You can think of it like a design gauntlet, where your design has to survive a whole series of tough new tests to get approved. You see, this new process isn't a straight line. You start with the traditional strength design, sure, but then you immediately have to check it for durability and serviceability. If it fails, let's say the computer model shows cracks that are too wide, you don't get to move on. You have to go all the way back and redesign. And for those top-tier select structures, the tests get way harder, demanding these super advanced computer simulations to see how the building would really behave under extreme stress. So, let's get down to the bottom line. What does all this actually mean for the engineers, the builders, and the people who own these buildings? The real-world impact is going to be profound. For starters, building owners are now pulled right into the hot seat. They actually have to sign off on the core design principles. But the real game changer is that engineers now have to put in writing the expected service life of the building in years. That one change, combined with all the new criteria, just massively ramps up their professional liability. And you don't have to take my word for it. As one expert put it, putting a specific expiration date on a building's design has some pretty serious legal ramifications. I mean, if a building starts to have problems before its official service life is over, you can bet that's going to open the floodgates for lawsuits. Look, at the end of the day, the goal here is fantastic. Safer, tougher buildings that last longer. Who can argue with that? But at the same time, it's placing a huge new weight of responsibility, complexity, and legal risk on the entire industry. So the big question really is, while the goal is noble, is the industry actually ready for such a massive challenge? That is something we're all going to find out.